And he has a longboard. He's supposed to be faster than all of them. He's still late. Okay, questions on homework?
Yes.
31, 37, 40, 41.
Not the whole homework.
No, I actually have questions on those.
1.4. You said 31?
37, 40, 41. No, seriously, 43.
What is 31?
43.
Wait, what's 31?
43, sir, 43. 43. Professor, 43, please.
Yeah, so to illustrate by graphing the function part, like that would be here.
Yeah, so you're just gonna make it like 0 equals 0, 0, whatever. Okay, so don't do that one. Let's just do that one.
Yeah, like you don't have to graph anything crazy.
So put 44 now.
37, let's look at this. Alright, be quiet, quiet.
Oh wait, should I ask my question about that one?
Well, 37 actually
I
isn't
got
that
two
bad.
answers.
43.
What was the trouble with 37?
Okay.
Just plug
Okay, okay. I got two answers. But I
Just
got
like plug in 3,
and 12.
like it's
Oh, yeah.
continuous. Right, that's just 0.
So can't you also do the absolute value of x minus 3, which is x plus 3, and then do it that way?
It will be negative x.
What? No?
Can't do that?
No, because this guy, x minus 3, is equal to two things, right? It's equal to it's x minus 3 or it's minus x minus 3. What are the conditions?
That's negative 3, 0.
It's x minus 3, x is greater than or equal to 3, and it's less than 3. But as x approaches 3, in either case, you still get 0. Right? You get 0 and negative 0. It's still going to be the same.
So replace it with 43. That's enough.
41 is actually a little more interesting.
Professor, let's have one question from that.
You have a question?
So let's say whenever you can plug in whatever it is, can you just plug in?
Yeah, that's it. This is called the direct substitution.
As long as you don't have the 0 on the denominator, right?
Yeah, as long as it's defined. So no 0 in the denominator, no negative
So what if-
square roots, things like that.
What about in the numerator?
Huh? 0 in the numerator doesn't
It's
matter.
okay, right?
So number 43, it approaches from negative and then also from positive. How do you do that one?
43, was that a sign?
Yeah.
Let's look at 43, so we want to find several limits. Okay, so let's look at the limit as x approaches 2 from the right of the index. Okay, how would you actually do this?
Just x minus 2, x plus 3.
You can't cancel. They're actually not the same thing. This is an absolute value, it actually matters. This guy, it's two different things, right?
X
So
minus 2 and
this means that this function is actually equal to, it's x minus 2 times x plus 3 over x minus 2, provided your x is greater than or equal to 2, then you can cancel. Or it's going to be the negative of this. Provided your x is less than 2. So one is actually the negative of the other, depending on which side of 2 you're on. Right, so the one-sided limits will probably give you different answers here.
How come you made it parentheses in there?
it's
Split it up.
That's what absolute value means. Right? If it's bigger than 0, which means x is bigger than 2, you just can take away the absolute values. If it's smaller than 0, then you have to put a negative sign. Right? This is the definition of absolute values. And so in part A part 1, they ask you for the limit as you approach 2 from the right side of g of x. So which one of these functions would occur? Right, you're bigger than 2 if you're approaching 2 from the right side. So from the right side, you're looking up at this function, and you just plug in 2, because now you cancel the problem. That's just 5. The limit as you approach 2 from the left of g of x would be, from the left means you're a little less than 2, you're coming from this side, so you look at the bottom function, and that will be negative 5. And so, does the limit exist? Answer is no, because the one-sided limits don't agree, right? The limit only exists if from the left and the right they exist and they agree. Sketch the graph. But if you could, if you'd like, it's just a matter of sketching the x plus 3. You can literally sketch the part that's left over, but you just put a hole where x equals 2. So if you wanted to sketch it, you could have. Just like at 2.
Negative 5.
What?
2 negative 5 and 2. Negative 5 and 5.
Yeah, you go up to. This is 5. I should have drawn this horizontally. 5 and negative 5. So here it's just like a line with positive slope, while down here is a line with negative slope. So it looks something like that. And you can choose which one here you want to leave on the older. Well, they both have to be holes, because it doesn't exist when x is 2, right? Because you divide by 0.
So Professor, on this problem, the graph cannot be anything, right? Because it's absolute.
Graph what?
Like, yesterday you just graph whatever.
You wouldn't just graph whatever, you have to graph this.
Yesterday there was no.
Yeah. The thing is, you just have to remember with absolute values, it matters if you're to one or the other side of 0. So you might have to change the sign. 40. Someone asks 40. Limit as x approaches 2 of 2 minus the absolute value of x over 2 plus x. How do you do that?
It equals 0, right?
Is it 2 or
Negative 2.
it's negative 2? Right, because 2 wouldn't be a problem.
You just take out.
So remember absolute.
You factor by negative
2 minus x over 2 plus x over like the negation. That's just x or negative.
Once you take it as positive x, then you take it negative x.
It's negative 2. What does that tell me about absolute value? I can rewrite this without absolute value, actually. So what would I actually write? It would be 2 plus x. Why would it be 2 plus x? Because you're smaller than 0, right? Absolute value x is x when you're bigger than 0. It's minus x when you're smaller than 0. So this thing here, you can just replace with minus x. Minus a negative x gives you plus x. So the limit is just 1. Because you're less than 0 here, so you know what to replace it with. You just replace it. How about 41? say to that? Right, you're approaching 0 from the left side, right? Which means you're a little smaller than 0, which means absolute value x gives you the value of minus x. So this is actually just the limit as x approaches 0 from the left of 1 over x plus 1 over x. Limit as x approaches 0 from the left of 2 over x. So as far as 1.4 is concerned, this doesn't exist, but when we get to 1.6, we're going to call this negative infinity. Minus infinity or does not exist with our 1.4 knowledge. Let's see. Would it matter if you're coming from the right? If you're actually approaching 0 from the right side, what would this be? Right, because this guy, absolute value, since they're positive, would return just x. Right, so this will actually be 1 over x minus 1 over x. Well, that's just 0. The answer would actually be 0. So this is a function that, it's approaching 0 somehow from the right, but it goes to negative infinity from the left. It sort of breaks into two pieces.
Is it negative infinity or 0?
Well, this is a different question. This is 42. 44. Forget the sketch part. I'm not actually sketch that. X approaches 1 from the left. Approaches 1. G of 1. Then there's x approaches 2 from the left. Then there's x approaches 2 from the right. Then there's x approaches 2. Okay, what's this? 1, you're coming from the left side, which means you're less than 1, so you're looking for the function that describes it at less than 1. This is just the function x. As you approach 1 in the function x, you just come over 1. Or this one.
Because it's not just function, they always say 1 from both sides. 3.
Well, we know coming from the left we get 1. What about coming from the right? Which function would you look at? Look at this one, right? So they're a little bigger than 1. It would go to 2 minus 1. It will also give you 1 from the left. So this is 1. Because the left and right side will be the same. What is g of 1? 3. Right? When x is equal to 1, your function is 3. Here's a bonus question. Is g continuous at the value 1?
Yes.
No. Limits do not agree with the value of the function. Right? This would have to be 1 in order for it to be continuous. 2 from the left.
Negative.
Which function would I look at? 2 from the left. The third one. You're a little less than 2. You're looking at this function. It's like this is what in 2.
Negative 2.
2 from the right.
From the negative
Look at this one.
you get negative 1.
So here you put in 2, you get minus 1. So what's the limit as you approach 2?
It's not like this.
This one? No, there's only one. Right, when you're coming from the left of 1, you look at this function. When you're coming from the right of 1, you look at this function.
I think you forgot to put the plus sign in.
Was there a plus sign?
No.
Isn't the x equal 1 also considered?
No. Remember, limits don't care about being at the point. You care about getting close to them. If you're at 1, I don't care. It's just, are you coming from it from the right or the left, and what's happening?
So you're coming for like, for the third one, like 2 minus x squared, you have to plug in 1, right?
Correct, yes.
So you get 2 for, oh,
Um,
I mean, oh, sorry.
2 minus 1 is 1. Okay, let's get to it. Take out your scrap paper. What?
55.
Oh, yeah.
Oh yeah, it's 1/2. 55 is 1/2. How do you get 1/2?
Multiply by like 1 over sine theta, 1 over sine theta.
How did you guys do this one?
Just get rid of theta. Get rid of theta by dividing by theta.
You divide the numerator and denominator by theta. That was the trick. You divide this by theta, and then divide this by theta, divide this by theta. This obviously goes to 1. We know the limit as theta goes to 0, tan theta over theta also goes to 1. And sine theta over theta also goes to 1. So this just goes to 1 over 1 plus 1.
Do I stop the recording?
Yeah, you can stop. We're going to do